Hey everybody, in this video we will be constructing a binomial distribution and the histogram associated with that. So let's just go ahead and dive right in. So as you guys remember, the parameters of interest as part of our binomial formula for the probability of a binomial distribution is the probability of success and failure, the very success-failure type of trials, where in each trial you have a probability of success. This suggests that there is a binomial distribution. Next is the number of trials. That's important, and we want to figure out the probability of a certain number of successes, and that will be the so these P, Q, N, and Y are the variables of interest. So based on these, we will be able to say the probability of a certain number of successes. So for instance, if you have a production process which produces defect items with 25% chance, so any item which has been manufactured has a 25% chance defect, and the question is, for instance, what if you have 10 units that you produced, and what is the probability that you will have three defects or 4 defects out of those 10 units that you produced? So that's a binomial event, and we will use binomial distribution in general, the binomial formula, to evaluate those type of questions. All right, so let's just write some numbers here. So suppose that the probability of success is 0.5, or we can just check something interesting. Suppose that the probability of success is 0.75, probability of defect or failure is, as a result, 0.25. It is not recommended that I write probability of failure just manually like this. Instead, I will do 1 minus the probability of success. Number of trials, suppose that there are 10 trials, and number of successes, suppose that we want to see if the probability of success is 0.75, and I have 10 trials, what is the probability that I will have exactly 5 successes, for instance? Does that make sense? So the probability of success should be, this is the formula, right? Let me just write down what the answer to that question will be. So we will use the combination of 10 choose 5. Out of the 10 products, what's the probability of 5 of them will be successful, right? No defect, for example, times the probability of success raised to the power 5. 5 of the outcomes are successful, times the probability of failure raised to the power 5 of them will be failed, right? 10 minus 5. So open parenthesis, it's really this number minus this number. I hope that makes sense. And that's pretty much it. If it's confusing the way I wrote it, so if you want, you can even put additional parenthesis signs. So just to make sure that, oops, that's not a parenthesis sign here and sign there. That's the second part. And the third part, the failure part, this one and this one. So press enter. There you go. If you want, we can also put it as a percentage. There you go. Maybe more decimal place. So if the probability of defect is 25% for any manufactured item, and suppose that you manufactured 10 items, what is the probability that you will have 5 of them with no defect and 5 of them with defect? The probability is only 5.8%. Now we want to construct a histogram for this distribution, right? And for that, what we will do is not only for the probability for 5 success and 5 failure, but we want to also calculate the probability of 6 success and 4 failure, 7 successes and 3 failures, and so on. All of the possibilities here, right? So let's just go ahead and do that. So what I will do is here I will write the number of successes. There you go. Here it will be the probability of having that many successes. So the number of success, if you're running 10 experiments, the number of successes can be as low as 0. or it can be as high as 10, right? If you're running 10 experiments, you might have 10 successful outcomes. That's the max. So reality is uncertain. One of these will be reality in the end. And the question is, what is the probability of each of them realizing? So the probabilities are basically the same thing that we just produced here, right? We want to write the formula all over the place. Let me just rewrite the formula so everyone is on the same page. So we want to find the combination of, so this one, we want to make sure this one is fixed. Choose this number, these are the successes, fix this one too, close parenthesis, times, open parenthesis, probability of success, fix that, raised to the power, how many, what is the number of successes now? Number of successes is this number, and we don't want to fix it. Times, open parenthesis, probability of failure, raised to the power number of failures, which is really this number, fix it, minus this number. This one I will let it flow, right? That's it. Just close parenthesis, close parenthesis. That's pretty much it. So that should be the desired probability. Now the good stuff is if I double click, it will automatically create the desired probabilities. However, that's a problem because probability can never be. All right, so where did I mess up here again? Okay, let me go inside the cell to check. Combination B6, number of trials, B7. Oh, sorry, I wasn't supposed to choose this one. I was supposed to choose this number. Okay, so that I see where the mistake is. So let's just delete that. So let's do it again. F2. I wasn't supposed to fix this one. This one is supposed to float, and except the number of successes should be this number, not that number. All right. I should choose from this. Okay, there you go. Now it should work. It's a probability which is literally 0, right? Because that means 10 to the power minus 7. That's a tiny number. Yes, now this is more reasonable. How do I know the answer is correct? What you can do is you can just add up the sum here. If you take the sum of all those numbers, if they add up to 1, it means you're in good shape. Yes, that's it. In fact, let me just go ahead and add that sum over here. That's just for checking purposes. And actually, you know what? We'll have now ready to construct our histogram, I would guess, right? So there's a couple of different ways you can construct a histogram, but I'll do the simplest one. I'm just going to, and by the way, these numbers are pretty ugly. I might as well just put them in percentages. There you go, and more decimal place of accuracy. So if the probability of success is 75%, the most likely outcome is that in your production process, you will have either 7 or 8 non-defect products, right? So which is perfectly makes sense. All right. Yeah, I was about to construct a histogram. Now, there's a couple of different ways. I think the one that I prefer is the following. I'm just going to choose the probabilities first. Insert a column chart. There you go. Except that, as you can see, the x-axis numbers, they are not accurate. So what I will do is I need to format that. I need to choose from these, not starting from 1 to 11, but from 0 to 10. Right, so these are my successes, right? So what I can do next is right click and select data. There you go. So the chart area is correct, probability is correct. So I want to edit the horizontal axis. So just press edit and make sure it selects the cells from here. That's pretty much it. Now press OK and look, it's updated. Now a couple other stuff. This is just cosmetics. Right click. Format the data series, make sure there's no gap, and fill in. So the fill is no fill, and the border is solid border. Yeah, so this is good. I think in fact I can even make the border a little bit thicker. There you go. All right, so this is a clear histogram. If you want, you can even add percentages on top of this column. So let's just go ahead and do that. Add data labels. There you go. So you can see the percentages of each outcome. So now this is a probability distribution. So let me see. yeah, I think I'm happy with what we did here. So one thing that we can also edit is the title. I know this is the desired probabilities of successes here, but I want to check the probability in this case. What if the probability here is, for instance, 0.75? What if this is 0.5? The probability distribution is automatically updated. I love this. Do you guys see that? Or if this one is 0.3 or 0.1, very unlikely that you will get a successful outcome in any individual thing. So even when it's very unlikely that in your production process you will have a successful item manufactured, when you repeat that experiment 10 times, the probability that you will get one correct is 38%, so which makes sense. There's a couple of things I want to change in this picture here, right? That's what I was about to say. One of the things is I want to change the title, and so let me just move that here. This is, remember, this one is actually just to check the validity of the probabilities. Sum of probability, validity of the table. If this number is not equal to 1, and it's supposed to be equal to 1, if it's not equal to 1, it means there's an error, right? If correct, oops. If correct. All right, there we go. So the title of the histogram, I want to change that. So the way I will do it is I will use something called concatenation. So this title, I will pick it equal to right from the content right here. Does that make sense? So for instance, right now it shows blank because there's nothing here. But if I write 13 here, this is the name of the title. Isn't that amazing? So what I will do here is the following. This is the title of my histogram, right? So I will write the following. I will write a formula with the following. Anytime I write a text, probability distribution of or I can just say binomial probability distribution with. All right, there we go. Binomial probability distribution with. All right, so this is important now. Space ampersand sign. Oh, actually, oh shoot. Okay, so right now we are in the middle of it. Okay, so I need to make a couple of corrections here. With n equals, all right, perfect. Now the concatenation sign, n equals this number of trials. Another concatenation, quotation. Anytime it's a text, I need to put it inside quotation. Anytime it's a number that I'm pulling from somewhere else, you see what's happening. Concatenation, comma, blank. The probability of success, right? P represents probability of success, is equal to, close parenthesis, concatenation sign, this number here. Let's hope it works. Yay! All right. So for instance, if in this one it is 0.2, we do so success, probability of success is 0.2. That's the new shape of the binomial distribution here with 10 trials, and P is equal to 0.2. Does that make sense? P stands for probability of success, Q stands for probability of failure. All right. One more thing, and this is amazing, this is really good. I want to make this table a dynamic table. Dynamic means the following. If I were to change this number to 20 trials, now what it does is it only shows a portion of the reality. So what does that mean? What it means is, so this is the probability. If you make 20 trials, the probability of none of the trials are successful. If you make 20 trials, the probability of one of the trials are successful, and so on. But wait a second. If we have 20 trials, there's a chance that 11 of them, 12 of them, 30. So this table was supposed to be all the way to 20, right? So how do I make it a dynamic table? The way is very easy. So what you do is you select this, and then you press Ctrl T. It will automatically create a table. My table has headers too. Perfect. Now this table, as a result, is a dynamic table. So what it does is the following. So you guys will hopefully enjoy this. Let me make it slightly smaller so I can see the full table. So if I were to add a new row here, because I know that, for instance, here, if we make it to 20, check what happens. The table is updated. Sorry, the histogram is updated, but how about the table? Now, I need to add new rows here, right? Because all the way up to 20. 11. Look at that. The probability is automatically calculated. Do you see that? 15, 16, 17, 18, 19, 20. If I write 21, it will give me an error message or something like that. 21, yeah, because it can't be, right? So the binomial, let me just get rid of that so you can just make it, let's just delete that. Okay, there you go. So what it does is the Excel understands this is a data set altogether, and anytime I add a new entry here, it automatically expands the data set. This wasn't the case if I remove this data table feature, right? Does that make sense? For instance, let me go all the way back. Check what's gonna happen. So suppose that I remove this data table feature. I should have said that earlier. All right, so one more. Okay, there you go. So this was initially what it was looking like. When I add 11 here, there's no automatic calculation. Even if there is an automatic for instance, let's change it. Hold on. Actually, there might be an automatic calculation after all. Let me check. For instance, change this to 20. All right. So if I enter here 11, actually, yeah, there's an automatic calculation. The problem is this table didn't automatically update. Do you see that? So the calculation here is correct. Yes, it automatically expands the data table, like the calculation, but the histogram is not affected from it. So for that, the best way is, like I said, just select and then Control T, and that's it. So now it's a table altogether. Here I might want to just there we go. Now what I can do is, if for instance there's 12 experiments where this one is 0.4, for instance, what I can do is 11 and 12, right? So I need to make sure 12, and look at that, the picture automatic. Obviously 0 percentages, it doesn't matter. For instance, if I increase the number of probability of success, though, it will show up some number over there like this. Wow, so it's pretty good, right? Very, very neat. So this is how we construct probability distribution. This is the example of a binomial distribution, but it works for any discrete random variable. Hope you guys enjoyed that. So in this video, what we did is we went over the binomial formula, and then using the binomial formula, this formula here, we were able to calculate individual probabilities, from which we were able to plot them into a histogram, a chart, a column chart. And then along the way, we learned how to create the table title, the histogram title from another cell. And here it's a combination of text with formula, so that's why we used ampersand signs here. So it was pretty cool, I think. And also we looked at dynamic tables as well, so it's another really, really nice feature. So I hope you guys enjoyed it, and looking forward to see you guys in our next lecture.